Serverless architecture is software that runs without an addressable server. Serverless is made possible by two types of technology: platform as a service providers like Auth0 and Heroku and Firebase, and functions as a service like AWS Lambda. With both of these technologies, we can program logic that runs without being deployed to a server. And by using platform as a service together with functions as a service, it really becomes a bright future in terms of how easy it is to manage our infrastructure. Functions as a service are cheap and scalable. Write your code for a serverless function, and the cloud provider will cheaply deploy and execute that function on some server somewhere. The difficult part is maintaining state. Since serverless compute instances are ephemeral, you are not dealing with a system that will keep track of your state. It's going to disappear eventually. The ephemeral nature of serverless code requires us to shift our thinking, but the dramatic cost and simplified scalability make it well worth the effort. Serverless functions can add complexity in exchange for lower price and excellent scalability. Serverless platform as a service offers lower complexity at a slightly higher price. A serverless database like Firebase handles database scaling and gives you a nice web interface. A serverless machine learning platform like Google Cloud ML gives your models scalability and controlled deployment. A serverless authentication service like Auth0 manages your authentication. In addition to authentication, Auth0 has built a set of tools to allow SaaS companies to extend their platforms into a sandbox code execution environment. Bobby Johnson is an engineer at Auth0, and he joins the show to describe the toolbox that Auth0 has developed: authentication, web tasks, and extensibility. And we also talk about how the world of serverless architecture is evolving. Full disclosure, Auth0 is a sponsor of Software Engineering Daily. Simplify continuous delivery with GoCD, the on-premise, open-source, continuous delivery tool by ThoughtWorks. With GoCD, you can easily model complex deployment workflows using pipelines and visualize them end-to-end with the value stream map. You get complete visibility into and control over your company's deployments. At gocd.org/sedaily, find out how to bring continuous delivery to your teams. Say goodbye to deployment panic and hello to consistent, predictable deliveries. Visit gocd.org/sedaily to learn more about GoCD. Commercial support and enterprise add-ons, including disaster recovery, are available. Thanks to GoCD for being a continued sponsor of Software Engineering Daily. Bobby Johnson works at Auth0 as a developer evangelist. Bobby, welcome to Software Engineering Daily.
Hi, Jeff. Thanks for having me.
Let's start by talking about authentication at a high level. We're going to get into serverless and its relationship to authentication.
Okay.
But just talking simply about authentication, why do applications need authentication?
Applications need authentication to ensure that code is executed by people who have authorization to execute that code.
And if I have a basic website with a username and a password login, how does authentication work?
Sure. Well, that's a pretty heady question. It really depends on how you have your application set up, but typically you have a username and a password that's sent to some back-end service that validates those username and passwords, identify you uniquely within the system.
Mm-hmm. Well, let's go a little bit deeper.
Mm-hmm.
So, what's going on? What's the contract between the client and the server in just a basic authentication pattern with actual servers, the kind of thing that we've been dealing with for the last 20 years?
Sure. Username and password is sent by the client to the server. That server then checks the username and password are valid.
So after I'm logged in, how does an application keep track of whether I'm logged in and who I am?
An application once the authentication request is complete, some form of token is passed back to the client that each subsequent request passes that token back to the server. So the server knows on each request who you are, basically, via that token. And so that token can have varying levels of complexity, right? It can just be a simple session token that identifies a session that's open on the server. Or it could be like a JWT full of claims of who you are and what you're allowed to do within the system.
And tell me more about the varying levels of complexity. What are some different things that an authentication token can have?
Sure. Authentication token could identify your authority. So who says you are what you are. So if I'm authenticating, like maybe using my Google or Twitter or Facebook accounts, that authority may be a portion of that token. Information about you can be encoded into that token. So your email address, your name, that sorts of thing. And maybe claims related to the specific application that you're using. Like, are you an administrator? Are you allowed to create things within the application?
And the client maintains the authentication token, is that right?
Well, the client maintains the authentication token in terms of handing it back with each request and managing any type of maybe refresh token scheme that might be involved in authentication. So potentially the token could be handed back to you with a expiration of 3 minutes, and after 3 minutes or slightly before 3 minutes, you want to request a new token to keep the session live, right?
Tell me more about how that management of authentication tokens works and how often those tokens get invalidated by a server.
Sure. So that's kind of based on configuration of your provider and how you want that set up. It's kind of dials that you can tweak. It's getting a little maybe into the weeds on the identity product at Auth0. I'm actually a evangelist for the Extend and Web Tasks products at Auth0. So going any deeper than basically what I've explained is maybe a little outside my...
Sure, no problem. Then we'll dive into the Auth0 related stuff shortly.
Okay.
But I guess talking a little bit more about just basic authentication. I mean, what's preventing somebody from stealing my authentication token and just authenticating as me?
Sure. Well, typically you want all that traffic going over HTTPS, a secure channel that doesn't allow any type of man in the middle to get access to that token. The token is typically also encrypted by the service itself, so only it can decrypt that token to get at the values.
When I use a external provider like Twitter or Facebook authentication to some external app, how does that work? Is that any different than the basic password login that we're talking about in authentication?
Yes, absolutely. Typically, you are handing off a portion of your authentication flow to that provider itself to do the login portions and then provide the token back out. That communication happens both between the authentication provider, your client, and your backend services. So there's communication line between Twitter and the backend service to ensure the token issuing is secure.
We have done many shows about serverless technology, but we've not focused on identity. So if people are totally unfamiliar with serverless, you can go back into some previous shows. Serverless is a broad term, just to refresh people's memory. You could be talking about a service like Heroku or Firebase, where you have, I guess with Heroku, you still have a notion of servers, but with Firebase, for example, you just have an abstraction that represents a database, and you don't have to manage the servers that underlie that database. It's not like an addressable server. It's more like a blob of storage, essentially. Same thing for Amazon S3 or Google Cloud Machine Learning, where you're just interfacing with this service and some opaque endpoint, and you're not addressing servers. And then on the more contemporary level, serverless means functions as a service. Amazon Lambda Google Cloud Functions, which are executable blobs of code that will be scheduled onto some machine on an Amazon or Google data center, and it will be executed cheaply. But since you're not addressing a server, the underlying infrastructure might shift around. And so, we get these benefits out of serverless functions as a service, like scalability and low cost, but we have some issues because we no longer have a server as an addressable entity. Have I described the world of serverless in a way that matches your description of it?
I think you did a pretty good job of describing it. I think the big difference between using a service like Heroku and using a serverless service is you're deploying to Heroku an application as a unit, a set of functions that interact together. And when you go to scale out on Heroku, you're scaling the entire application itself. Whereas a function as a service platform allows you to do that scaling at a much more coarse level. So I can deploy several functions that are targeted and very narrowly targeted to do one thing and one thing well, and I can individually turn the dials for each one of those to scale up as necessary, with the ultimate goal of I'm only paying for the resources that I'm using, not paying for an application to be sitting out and available, whether it's processing information or not.
In the model of authentication that we explored, you've got this relationship between a client and a server where the client sends a username and password to log into a server, and the server responds with an authentication token, and they maintain a little relationship with each other. But if you have this shifting sands of underlying infrastructure where the server that you're communicating with might essentially disappear because the code gets scheduled away from it, this seems like we have to figure out a different way to manage the authentication. Am I explaining things correctly?
Yeah. So in terms of at least web tasks, that authentication is really kind of up to you how deep you want that to go. You can do a simple shared key type authentication, where each request hitting an endpoint has to match a key that's defined within the web task itself, or you could rely on an external provider like Auth0 to do that key validation for you. Right.
Can you go deeper on those two options? If I'm building a service where I want to use functions as a service, these ephemeral blobs of compute, I want to take advantage of these, but I also want to have identity associated with my application. Describe those two options once again in a little more detail.
Sure. So basically the two options I was describing is going very simply with just a shared key type of authentication scheme where, say, you put a function out into the service that you want to ensure that only people who are authorized to call it are authorized to call it. You provide that person with a key that they pass with every single request. I'm talking about this in kind of a manual process, right? But then you could also hook into Auth0 as an identity provider to take whatever key that is sent by the client to validate that it's a valid key in terms of Auth0's identity product saying, yes, this is a valid key. Am I saying that clearly enough?
Yeah, okay. No, I understand.
Yeah.
So talk in more detail about how Auth0 handles identity management, because this is essentially identity as a service, and we're going to go into a little bit more detail in a sec, but just give an overview for what the product does.
Sure. Auth0 identity basically is a drop-in component to your application that handles all authentication and identity for you, and it kind of allows you to merge in any type of identity provider that you would like to consume within your application, like we talked previously about social logins like Facebook and Twitter, but we can also consume SAML logins, traditional username and password logins, and we're managing all of that for you to where none of that data is stored in your application. So, there's the old chestnut about never try to roll your own crypto. The same could be true about never trying to roll your own authentication and identity. We will handle that for you in a secure manner, and we have some of the best engineers in the world working on that to ensure it's the highest quality possible.
So if I'm using Twitter login, though, like let's say I want to build an app that has Twitter login, why wouldn't I just use Twitter? Because in that sense, Twitter is kind of being my authentication provider. How would Auth0 differ from that kind of outsourcing of an authentication service?
Sure. So it's relatively easy to set up authentication through Twitter directly in your application, right? But you have to wire up all those callbacks and handlers yourself just for Twitter. Now you want to implement Facebook, you have to go through the same kind of set of tasks and boilerplate code to implement Facebook as well. With Auth0, you can basically go in, flip a few toggle switches, add a couple keys, and all of that infrastructure is in place for you already. And it's separated from your application code, right? So if 6 months from now you want to come in and you want to add additionally, say, Azure AD-based authentication, you would do that in the Auth0 dashboard, and it wouldn't necessarily affect your application in any way other than the ability to be able to log in with Azure AD, and the application continues working the way you expect it to.
At Software Engineering Daily, we need to keep our metrics reliable. If a botnet started listening to all of our episodes and we had nothing to stop it, our statistics would be corrupted. We would have no way to know whether a listen came from a bot or a real user. And that's why we use Encapsula, to stop attackers and improve performance. When a listener makes a request to play an episode of Software Engineering Daily, Encapsula checks that request before it reaches our servers, and it filters the bot traffic, preventing it from ever reaching us. Botnets and DDoS attacks are not just a threat to podcasts. They can impact your application too. Encapsula can protect API servers and microservices from responding to unwanted requests. To try Encapsula for yourself, go to encapsula.com/2017podcasts and get a free enterprise trial of Encapsula. Encapsula's API gives you control over the security and performance of your application, and that's true whether you have a complex microservices architecture or a WordPress site, like Software Engineering Daily. Encapsula has a global network of over 30 data centers that optimize routing and cache your content. The same network of data centers are filtering your content for attackers, and they're operating as a CDN, and they're speeding up your application. They're doing all of this for you, and you can try it today for free by going to encapsula.com/2017podcasts, and you can get that free enterprise trial of Encapsula. That's encapsula.com/2017podcasts to check it out. Thanks again, Encapsula. Services that have multiple authentication types, like if I have authentication with Twitter and authentication with Facebook and Google and all these other, there's a bunch of enterprise login systems that we could also explore. What is the database of record for all these authentication types? How does that look? Do we try to create a N-to-1 mapping where there's a bunch of different login schemes that any user can log in with, or do you try to maintain a 1-to-1 mapping where, if a user logs in with Twitter and then they log in with Facebook, you give them two different identities, or how do you typically do that?
Mm-hmm. Well, usually we need some point of reference to be able to merge identities like that in the back end. So that is typically keyed on your email address. So when you authenticate through Twitter or you authenticate through Facebook, one of the demands we ask in that authentication cycle is give us your email address. And then we can search through our back-end systems for other accounts, typically, or not accounts, but identities that have that same claim. And it's up to you in the dashboard in Auth0 to decide whether you want to merge those two things together or not.
So I want to go from here to talking about web tasks, and I think the place to start there is with web hooks, and then we're gonna get into web tasks, and we'll talk about how that relates to serverless and authentication. But this is how we can start to talk about some usability layers that are being built on top of the serverless infrastructure. Obviously the value of the serverless infrastructure is that it gives you on-demand, really easy scalability and much lower cost. But with that has come some usability issues. So let's start with webhooks. Explain what a webhook is.
Sure. So a webhook is a very elegant solution to a very old problem. And that problem is when you put a software as a service application out on the internet for other people to come consume that application, eventually they want to use your application not just in the context of that application itself. We use several different SaaS offerings on the internet within a company itself, and we want those things to be able to communicate with each other. So in the example of maybe GitHub, when I have an issue that's logged in GitHub, I want something to be able to pop up in Slack for me to let me know that, hey, an issue was just filed on GitHub and I need to go address it. A webhook allows you a very simple method to subscribe to those events and have a payload be shipped across the internet to some endpoint to handle that event happening.
And describe the client-server relationship for a webhook in a little more detail. Maybe you could give an example.
Sure. So in the example that I just mentioned, filing an issue with GitHub on a repository, in GitHub you would go in and actually create a new webhook, provided a URL of where to send that payload, and then it's kind of up to you to implement wherever that URL is going to resolve to and handle the payload coming into your infrastructure. You might be lucky in that the other service that you're wanting to kind of wire together or glue together already has baked in functionality for handling GitHub webhooks, but it might not as well. You're kind of at the mercy of the two services for communicating together unless you want to implement it yourself and stand up an endpoint that's available on the web, secure it yourself, maintain it, and deal with any monitoring or scalability issues for servicing that webhook call.
Mm-hmm. How does a webhook compare to a system where I would make a remote call from my client to the server and then just poll the server? Because that seems like an alternative to this making a request and then waiting for a call back.
Could you state the question again? I didn't.
Basically there's two ways of getting information from a server that takes some time. So like you could have your client make a remote call to the server and then poll the server and just keep asking it, like, have you finished the task yet? Have you finished the task yet? Or you could make a call to a server that has a webhook, and then once the webhook finishes processing, it can call back to the client. Am I just kind of describing two different ways that you could have this kind of interaction? Is that the problem that the webhook solves? Is the polling problem?
Yeah, I believe so. And so instead of constantly hitting GitHub to say what issues are there any new ones, you can actually have GitHub notify you of new issues coming in, and that's fundamentally easier to work with, takes less resources.
Mm-hmm. What are the challenges for the provider of a service with webhooks? Is there anything difficult about setting up webhooks on your server?
Provider, like say for GitHub, does webhooks present a quandary for them?
Yeah, like a management. Like, is there any difficult management issues?
I wouldn't think there would be difficult management issues for the webhook issuer, right? Being able to fire off a webhook. It solves a problem for them of, my customers want to be able to customize the service that I'm offering, so I give them a way of being able to respond to events within my system, but all of the burden is placed on the customer themselves of how to actually do that response, right?
Okay. Are there any usability issues with webhooks that are worth discussing before we dive into web tasks? Like the shortcomings of webhooks that perhaps the web tasks ended up solving.
Sure. So I think what I just said is kind of the major red flag for me. Webhooks are a brilliant solution, like I said, to a problem that we've been dealing with since the 90s or maybe even before, and that's customizing a software offering for individual clients who want to be able to consume your application. But webhooks really solves the problem for the SaaS itself. It doesn't necessarily solve the complete problem for the customer that's using the product, right? The end user has to consider how they're going to consume the webhook calls in their own infrastructure, maintain that infrastructure, and any costs associated with doing that, right? Including internal organizational costs of developing new functionality, of responding to the webhooks. Am I saying that clear enough?
Yeah, it makes sense.
Yeah.
To explain to people further, a web task is a webhook with a server included. It's essentially a serverless webhook. Explain what that means.
Sure. So we like to use the term serverless extensibility, and it's a term that we coined to describe a pattern where SaaS providers take advantage of a serverless platform like Azure Functions, Lambda, to securely execute for the purposes of allowing customers to extend functionality of the SaaS product. Some really good examples of that are Twilio Functions and Auth0 rules. The ultimate goal of serverless extensibility is to remove that burden that I've been talking about that webhooks place on your customers to implement and maintain applications needed to process the webhook calls. Instead, you take that burden on for your customers by providing a secure execution platform directly as a part of your product.
Can you give an example of that? Explain that in more detail.
Sure. So, for instance, what Twilio Functions offers, or Twilio, if you're familiar with it, is a service that allows you to basically buy a phone number and then offers an API to be able to programmatically respond to phone calls or texts or that sort of thing. They offered webhook functionality, just like GitHub does. When a call comes in, a webhook is called with information about that phone call, and whatever you choose to implement at the other end of that webhook call can respond to the phone calls or text messages, and you can build pretty complicated kind of phone tree sort of systems, right? Brilliant product. Twilio is an amazing product, but it put that burden on you to be able to host the application yourself that's going to be doing the interaction with the application. So they created this new feature offering called Functions, which basically allows you right within their dashboard to wire up the callback and response system running in their serverless environment.
So what's an example of an application that I would deploy on a Twilio function?
Sure. Chatbot over SMS. So I send a SMS message to a specific phone number. Twilio gets that message inside their infrastructure, bundles up just like you would with a webhook, but sends it off to a function you've predefined to execute whatever logic you'd like to execute, and then respond back to the text message with another SMS message.
I see. So in contrast, if I were setting up my own, I'm like, I want to have a chatbot service where I can order a pizza via text message. And if I wanted to build that application without Twilio Functions, I would be building that, deploying it to a server somewhere on AWS or Heroku, or host it on my own server. And basically, I could use Twilio for the authentication of phone numbers and have my users send a text to a number that I have assigned. I've set up a phone number on Twilio's infrastructure. My users send a message to that phone number to order a pizza, and Twilio manages the request response of the phone number, but then I have to handle those messages with my own server And in contrast, with if I was using Twilio functions, they would be hosting the code, and then they would scale up or down the code for actually processing the pizza order.
Exactly. Yeah, you said it very well. Webhooks, we've already said, is a very good solution to a problem. The problem that we're trying to solve with serverless extensibility is the other side of the webhook. So once the webhook calls something, what is that something you're calling? And can we bake that thing directly into our platform so that it doesn't put the burden on you as a customer to have to go and create a AWS account or create a small application to service those webhook calls?
So the Twilio example, Twilio is not actually using web tasks, right? They're using basically something that is similar to a web task. But you're kind of giving that as an example for the kind of functionality where you would want to couple the API response with the provider. I guess what I should ask is, are there direct examples of people that are using web tasks themselves to kind of give a more direct example of web tasks?
Yeah, sure. So web tasks in Auth0 actually grew out of our own identity product in terms of Auth0 rules. So when a person authenticates using the identity product, a lot of our customers wanted some type of webhook-like functionality to be able to execute some bit of logic on every single login. So similar to what Twilio did, they had a similar problem. We built in-house a platform for being able to create these customizations and execute them securely, these customizations being custom untrusted code, and being able to keep them in isolation away from other customer instances, right? And the rules was incredibly popular for Auth0 and really helped us get a lot of success with our users. So we thought if this was a benefit to our customers, we could carve it out and make it actually a product into itself. And that product that I work on, myself and my team work on, is called Auth0 Extend.
Mm-hmm. Fascinating. Okay, so the idea is you had these Auth0 rules where every time somebody authenticated using Auth0, just to remind people, Auth0 is basically the service that takes the issues of authentication out of your purview, and it makes it quite simple, and Auth0 maintains your identity service and gives you lots of different ways that your users can authenticate, whether it's Twitter or Facebook or these other enterprise login services, Office 365, whatever. But when your users log in, maybe you want to do something like, let's gather telemetry data on a user after they authenticate for the first time. We want to also send a ping back to. We want to take their IP address and run it through some check and get more telemetry data on where they are, or we want to we want to send a message to some other logging server that we have to increase the user counts that have logged in today. We just want to have messaging or notifications or updates that are tightly coupled with people authenticating.
Yeah, definitely. The use cases are unlimited, right? The things that our customer would want to do at the time of a login attempt are unique to each individual customer, right? It's customization specifically for them. So you could imagine scenarios like wanting to whitelist domains for email addresses where we're only going to allow authentication through, for example.com, right? Or we want to blacklist certain API ranges, or we want to have a Slack message be posted every time a new sign up happens in our application, or a person authenticates within our application. Maybe that's a silly example, but there are customers out there who want to be able to do those sorts of things. And the question is, do you bake each one of those requests into your application directly, or do you give an extensibility point to your customers to be able to do that themselves specific to their tenant, basically within Auth0, and make it as easy as possible for them to go in and write that code for whatever specific use case they have and execute it securely so that it doesn't affect any other client within Auth0 as well.
DigitalOcean Spaces gives you simple object storage with a beautiful user interface. You need an easy way to host objects like images and videos. Your users need to upload objects like PDFs and music files. DigitalOcean built Spaces because every application uses object storage. Spaces simplifies object storage with automatic scalability, reliability, and low cost. But the user interface takes it over the top. I've built a lot of web applications, and I always use some kind of object storage. The other object storage dashboards that I've used are confusing, they're painful, and they feel like they were built 10 years ago. DigitalOcean Spaces is modern object storage with a modern UI that you will love to use. It's like the UI for Dropbox, but with the pricing of a raw object storage. I almost want to use it like a consumer product. To try DigitalOcean Spaces, go to do.co/sedaily and get 2 months of Spaces plus a $10 credit to use on any other DigitalOcean products. You get this credit even if you have been with DigitalOcean for a while. You can spend it on Spaces or you can spend it on anything else in DigitalOcean, and it's a nice added bonus just for trying out Spaces. The pricing is simple. $5 per month, which includes 250 gigabytes of storage and 1 terabyte of outbound bandwidth. There are no costs per request, and additional storage is priced at the lowest rate available, just a cent per gigabyte transferred and 2 cents per gigabyte stored. There won't be any surprises on your bill. DigitalOcean simplifies the cloud. They look for every opportunity to remove friction from a developer's experience. I'm already using DigitalOcean Spaces to host music and video files for a product that I'm building, and I love it. I think you will too. Check it out at do.co/sedaily and get that free $10 credit in addition to 2 months of Spaces for free. That's do.co/sedaily. How does that differ from a raw function as a service? How does if I'm deploying code to run in a web task, well, let's say to run in Auth0 rules, for example, which is Auth0 rules was this thing that was the first web task essentially, and you use that as sort of validation that this more general idea of code that you would want to run in response to on Auth0 login, this could be abstracted into code that you would want to run alongside an API service like Auth0 or Twilio or Salesforce or these other popular SaaS platforms that have turned into APIs, or they started out as APIs for developers in the case of Twilio. When you want to couple this functionality that's going to run in response to something that SaaS provider or that platform as a service provider is doing, and you're talking about this abstraction of a web task, how does that differ from just deploying that code on a raw function as a service like AWS Lambda?
Sure. Deploying that code on something like Lambda requires you to know how to do that, right? Whereas the rules system within Auth0's dashboard itself is baked right into the UI right there in your account. You get an editor right in your browser where you define the logic in JavaScript right there, and we do all the management of deployment, scaling, maintenance, and those things for you. So it's like I said, removes a lot of the burden on the customer from using our service, which makes them happy and they tend to stay with our service. The benefit for SaaS providers is that web tasks and Extend both provide more stickiness within your platform than traditional webhooks.
Do web tasks have the cold start problem that the functions as a service have?
Well, web tasks, the Auth0 web task technology that we've developed is very focused on execution with high fidelity, HTTP fidelity. So we go to great lengths to reduce the cold start execution.
Explain the cold start problem for people who don't know, who are not familiar with the serverless cold start problem.
Sure. So cold start, what we mean by that is that we don't, a request comes into an HTTP endpoint and there isn't necessarily something there waiting to respond directly to that HTTP request. So we have to set up some form of infrastructure to be able to properly handle the request. And with that, time can take. I'm explaining this horribly.
Let me see if I can word it correctly.
Sure.
So, and I know this stuff can get muddy. So,
Yeah.
AWS Lambda, for example, I'm going to deploy my code to AWS Lambda, and what that means is that whenever an event triggers the Lambda function to run, my code is going to get loaded onto a container somewhere on Amazon's infrastructure, and it's going to get executed. And I don't know where that container is. I don't have an ability to address it. I don't know how long it's going to be standing up, but it's going to address the response. It's going to address my request, and it's going to send me a response. And then it's going to be around for some time, and I can ping it with more requests. But that first ping to the function as a service has a cold start problem because the code that I've loaded into a Lambda function has to get, the code that is basically hosted on Amazon servers at that point, it has to actually get loaded into a running container in order to execute. Because the difference with functions as a service versus actual addressable servers is that the code is not always like in memory waiting to get executed for you. It's like a function as a service. It's a function you can call on demand. And this cold start problem could be an issue if you want to run stuff that's super responsive on functions as a service.
Very, very well put. Yeah, that was a great explanation of the cold start problem. And the way we go about solving that is that we've always got containers that are spun up and ready to accept a call. And if a container is not set up to handle a specific function already, we have a method to quickly deploy that code directly to one of those hot containers and respond to the call quickly. And because our focus is on execution in an HTTP scope, a request, we need to keep that cold start functionality, very low latency. So we try to, make that cold start functionality happen in, hundreds of milliseconds instead of, potentially a couple minutes.
It's pretty interesting. I mean, you think about serverless and just how dramatic the cost reductions are when we're talking about the raw serverless like AWS Lambda or GCP, and in that huge margin of cost reductions, there's this opportunity for all these other providers, such as Auth0, to stand up a little more domain-specific serverless functionality, and basically, you can offer serverless at a slightly higher markup to raw AWS Lambda or Google Cloud Functions, but it's still dramatically less than like what it would cost to run on your own servers. So I think it's kind of an interesting market that is cropping up between the actual compute and the raw serverless functions.
Mm-hmm. Well, while web tasks can be used to do similar things as other fast platforms, like you're saying, we like to think that we are fundamentally trying to solve a different problem. And that problem is the serverless extensibility concept that we were talking about earlier.
Okay, describe that in more detail, because I know you work on Auth0 Extend. What is that serverless extensibility you're talking about?
Sure. Serverless extensibility is a term we coined to describe a pattern where a SaaS provider takes advantage of a serverless platform to securely execute code for the purpose of allowing their customers to extend the functionality of their SaaS product.
It's like it almost seems like a sidecar. It's like I'm Salesforce. Today I have an API that you can use to build applications on top of, but if I give serverless extensibility, it takes more burden. It gives Salesforce the ability to accomplish more than on the Salesforce side of things than in the current model, where the client has to perhaps process the API request with more detail. Am I describing that correctly?
Yeah, the way I tend to look at it is that you're lowering the barrier of entry to, customizing your platform or your SaaS product to the point that you don't necessarily need, developers in the back end developing applications that process those webhooks, right? You could potentially have, I don't want to say lower skilled people, but not necessarily a developer go in and customize how your platform behaves to certain events, right? So we're lowering the barrier of entry by removing some of the burdens that might require a more costly solution.
Can we give another example? Because I think this is kind of a hard topic for me to understand personally, so I'm going to assume that there's some difficulty for the listeners to understand it. Maybe is there another example we can give? We gave the example of the pizza delivery service where basically you take some of the effort out of the client and put it onto the server. You basically did the same thing with the example with Auth0's what was the trigger? The thing that became WebTask? What was the original
Auth0 rules?
Right. Okay, so that was another example.
Well, you brought up Salesforce, right?
Yeah.
Salesforce is a customer relationship management kind of platform application. You could imagine if you were Salesforce and you were trying to sell this software to Fortune 500 companies or other customers, those customers start to come up with requirements of things they would like Salesforce to do for you. And each customer would have their own unique set of requirements of functionality that they would like to happen. So if you're a CRM, let me give you a couple of examples of things you might want to do. You're adding a lead into the system, and customer A would like to have some logic execute when the lead is added, that if the value of that lead is over, say, $50,000, we'd like a message to be sent directly into Slack. But customer B, what they would like to do when a lead is put into the system is to maybe call out to another service to gather or enrich some data about that particular lead. Like maybe all you have is a name and an email address. So you'd like to reach out to some service that would maybe, based on that email address, give you a Twitter handle, a Facebook URL, potentially any public address or something like that associated with the email address, and have that enriched into your lead data model and then stored within the system itself, right? Web tasks work really well for that type of glue code between services to get that business done. So similar to maybe you're familiar with Zapier, where you can use Zapier to kind of bridge or glue two different services together through a kind of a visual means. Web tasks are a more developer-focused sort of offering than Zapier. And that's just one potential use case, right? Writing that glue code between services and enriching data.
And if I'm just running all of that stuff, if I'm managing all that code myself instead of putting it into some kind of sidecar or putting it into a Zapier service, just zoom in a little bit more on why that's harder to do. If I'm the developer and I don't have access to these serverless types of management things, why is that harder?
Sure. Well, I mean, it's the context of your business. Do you want to spend resources and time doing these types of integration, or do you want to focus on your core business and devote all of your resources to that?
The Auth0 Extend product, so that's built on web tasks, right?
Yes. So Extend is our premium serverless extensibility product based on Auth0 web tasks. It consists of a backend infrastructure that securely handles execution of your custom untrusted code in isolation, but it also offers a white-labeled embeddable editor that is fully customizable and themable, as well as any monitoring or maintenance that might be needed for that backend infrastructure. We handle all of that for you.
Okay, I see. For a SaaS company, what you're really getting out of this is I think that white labeled editors, that sounds pretty cool, because like if I'm Salesforce, I can just now have a thing where people can drop in code that can execute in a way that is, it's flexible because it's any code can execute, but you can, I assume Salesforce would be able to tailor it to respond in ways that are domain specific to Salesforce. Like Salesforce could define a namespace or something that requests could respond to.
Sure. Yeah. I like to think of, we talked about Twilio functions earlier. I like to think that if Extend was in existence when Twilio was working on that, we could have made a play to say, Twilio, why don't you use our platform instead of building all that yourself in-house? And that's primarily the market we're going after with Extend. So the companies that have recognized this problem within their own platform and are making the choice of, do we solve it by dedicating our resources to building it, or do we look at something like Extend that is a drop-in serverless extensibility platform?
It's a brilliant product. It seems nascent. I'm very interested in this product, but are there a lot of other people that are interested in it at this point, or does it kind of feel like, oh, we're a little bit early, and this is a market that's going to develop, or is the market already popping?
Sure. We've got a nice funnel of interested parties and a handful of very engaged customers. But you're right, serverless extensibility is kind of a new concept that is starting to emerge out there, with Twilio functions being a primary example, but there are other examples out there. We've talked about Auth0 rules. There's also Stamplay, which is doing a similar type of serverless extensibility within their product offering. So companies are recognizing that they need to go beyond webhooks to entice more customers to come to their platform and use it, right? Webhooks is, like we said, a brilliant solution to an existing problem we've all been working with. We're attempting to make webhooks better and go beyond that to, like I said, lower the bar for people who are wanting to engage with these services.
When you go to a company like GitHub, and I have no idea if you've talked to GitHub or not, but you would say, hey, we've got this Auth0 Extend product, and we can give you a execution environment where programmers can spin up their own code. Doesn't that sound more appealing than webhooks? Is that kind of thing enticing to, because I'm sure whether you've talked to GitHub, or maybe we could talk about some other enterprises. I mean, what's their response? Are they like, yes, let's absolutely do this, or it's a little too early for us, or our webhooks are working just fine? How are they responding to that sort of pitch?
It really depends on the customer that we're speaking with, right? We've had people approach us because they've seen our marketing out in the marketplace, and they have this problem. They're feeling that pain. And we have also approached companies who offer webhooks and made the pitch to them, and they genuinely seem receptive, and we typically do some type of prototyping with them, proof of concept sort of thing, to kind of prove out the model. And so far, we've had great success with it.
Okay. Let's talk a little bit about the future. You're at one of the companies that is betting the most on serverless. Give me a picture for what infrastructure is going to look like in 5 or 10 years, the most cutting edge infrastructure from your standpoint of where serverless is today and where things are going.
Mm-hmm. Serverless is really allowing you to focus in a very granular way of just the logic that you want to execute. I could really see organizations being able to deploy entire applications out in serverless infrastructure without having to consider things like Docker images or VMs or those sorts of things and get very far. You mentioned earlier that I attended Serverless Conf in NYC this last week, and one of the compelling stories that came out of that was a Cloud Guru, which is an online training sort of website. And they were able to use serverless technology, including web tasks, to stand up their first iteration of their application offering over a weekend and gain considerable amount of traction. So that speed to market for them was definitely a boon that allowed them to be successful early on and iterate on their product quickly.
So there was no logging into an EC2 server. There was no logging into Docker containers. They built their entire infrastructure on services, basically.
Yeah, basically serving up HTML via S3 and then making any kind of API calls back out to simple serverless endpoints.
Who do you think, who still needs to maintain servers? Like in 5 or 10 years, what are the businesses that still need to maintain AWS instances?
Mm-hmm. Hopefully AWS, and everybody's moved to serverless to where they can focus on their core business and not be as concerned with infrastructure.
Is there a resistance from anybody who are kind of like nervous about deploying their stuff to serverless?
Well, there's always resistance to new ways of thinking and new ways of doing things, right?
Yeah.
My background over the past few years, I've done a lot of contracting for state agencies, and there are resistance within those state agencies to even considering using containers in the cloud, right? They want to maintain their own servers and that sort of thing. So you're always going to encounter that, but the longer a technology stays around and gets proven out, that resistance kind of deteriorates.
Yeah, because it seems like switching costs are not super high anymore. Like even if I start building infrastructure on any one of these services, most of them are just like very small isolated pieces of infrastructure. It's not, I think people maybe got an allergy to this when certain database providers or certain operating system providers really leveraged their relationships with companies that built on top of them and kind of set up an antagonistic relationship. But nowadays, your infrastructure is spread across a bajillion different providers, or in the serverless world, across so many different providers that nobody is irreplaceable. It kind of feels like.
Yeah, absolutely. You in the serverless space, you can look at projects like the serverless CLI that are attempting to abstract away the serverless provider aspect of your code base, right? So I can choose to write my functions and use the serverless CLI to deploy that function to Lambda, to Webtask, to Azure Functions, GCP, and have a single code base deployed out to all of those providers, right?
What was the coolest talk you saw at Serverless Conf?
Well, I really enjoyed Glenn's talk on serverless extensibility.
Okay, all right. Let's remove a little bit of bias from this.
Okay. Yeah. So Sam Croning's talk on his effort of launching a cloud guru using purely not serverless extensibility, but serverless technologies before that term was even coined was really eye-opening. I was kind of amazed at just how simple his initial application structure was really just based on S3, Auth0 identity, web tasks, and Firebase. And he was able to get something out there without considering servers or VMs or containers at all. It was pretty amazing.
I love Firebase. I love those other things you mentioned too, but I love Firebase. I've had great experience with it. Mm-hmm. Okay, well maybe I'll check out that talk. Bobby, it's been great talking to you.
All right, Jeff. I really appreciate it. Thanks for having me on.
Yes, absolutely. I think we covered a lot of great ground. Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges, while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks to Symphono for being a sponsor of Software Engineering Daily for almost a year now. Your continued support allows us to deliver content to the listeners on a regular basis.
Wow!